Chapter 4, Section 4.5, Graphs of Sine and Cosine Functions. Part 1. In this part of the notes, we're going to focus on sine functions. We're going to explore the graph of sine of theta. As we move our point around the unit circle, let's look at what the sine values do. So right here where my point is, my y value, sine, is at 0. Which is where we see this red point down here on the graph as well. It's at 0. As I go around the unit circle, my y value gets bigger until it gets all the way up until 1. That's the highest it gets. And now as I keep going, my y value is going back down to 0. So see how my red dot went up to 1, back down to 0. And now our y value becomes negative. So it goes down to -1, down here. And then back up to 0. So as I'm going around the unit circle, my y value oscillates about 0. So see how it's going up above 0 all the way to 1 and then back down past 0 all the way to -1. So this is called a sinusoidal function because it repeats over and over, oscillating about one number. Here is a table of values for y equals sine of x. You see our x values are in radians, and our y values are just the y coordinates of the points from the unit circle. Some properties of y equals sine of x are the domain is -infinity to infinity, the range is -1 to 1, the period is 2 pi, and the function is an odd function. Let's talk about amplitudes and periods. So the amplitude of the graph is how high the graph goes from its middle point. Or you can think about how tall the peaks and the valleys are of the graph. We always get this from the absolute value of a. So the number out in front of our equation, whatever the positive value of that is. The period we find by doing 2 pi divided by b. b is the number inside of the sine function being multiplied by x. So the period is just how long it takes to get through one full cycle of the graph. Here are some steps for graphing variations of sine of x. These will be really important to have down in your notes. The first thing we're going to do is identify the amplitude and the period, so absolute value of a, and 2 pi divided by b. Second thing, we're going to find the values of x for the 5 key points. These key points are going to be 3 intercepts and a min and a max. We start by finding where the cycle begins, and then we do our period divided by 4, and we add that on until we have our 5 points. If we have a phase shift, then we're going to start at x equals c over b. If there's not a phase shift, so if there's no c value, then we just always start at x equals 0. Number 3, to find the y values for those 5 key points, we're just going to plug those x's into our equation and evaluate. Number 4, we're going to plot and connect those 5 key points with a smooth curve. And number 5, if we need to extend the graph either to the left or the right, we can. Each problem will tell us if they want us to graph it for just one period or if they want us to graph it from, for example, 0 to 8 pi. So we might have to do multiple cycles of our graph, just depending on what the problem says. Example 1. We're going to determine the amplitude of y equals 3 sine of x, and then we're going to graph both y equals sine of x and y equals 3 sine of x from -pi to 2 pi. So step 1, we're going to identify the amplitude and the period. Amplitude is just the absolute value of a, which in this case is 3. And the period we get by doing 2 pi divided by b. In this case, b is 1, so my period is just 2 pi. For step 2, we're going to find the x values for the 5 key points. We start by finding the period divided by 4. And then we're going to find our starting point. Since we don't have a phase shift, our starting point is going to be at 0. I used x sub 1 to say that's my starting point. My other 4 points, I'm going to use x sub 2, x sub 3, x sub 4, x sub 5, just to show that those are my 5 key points. So now the way I get the rest of my key points is I just add pi over 2 to the previous one. So 0 plus pi over 2, pi over 2 plus pi over 2, pi plus pi over 2, and then 3 pi over 2 plus pi over 2. So we're just taking the previous x value that we found and adding pi over 2 to it. Next thing we're going to do is find the y values for those 5 x values that we just found. And the way that we're going to get those is by plugging the x value into the equation for x and simplifying. So this first one, we're plugging 0 in for x. And then I can evaluate this. I know that when my angle is 0 degrees, my y value, my sine, is 0. So we have 3 times 0, which equals 0. So here's my first point, 0, 0. Then we're going to plug in pi over 2 and evaluate, and so on and so forth. Make sure you pause your video if you need to write these down slower. For step 4, we're going to plot those 5 key points, and we're going to connect them with a smooth curve. Make sure that your x and y values are always labeled. Next, we need to extend our graph. So the problem told us to graph y equals 3 sine x for negative pi to 2 pi. So what I have graphed right now is from 0 to 2 pi on the x-axis. So I need to work my graph to the left all the way to negative pi. Looking at this graph, I can confirm that my amplitude is 3. And my period is from 0 to 2 pi, so it's 2 pi long. In orange, I went ahead and graphed y equals sine of x so that we can compare our orange and green graph. We can see that the green graph has been stretched by a factor of 3, while the orange graph is still just having its highs and lows at 1 and negative 1. Example 2. Determine the amplitude and period of y equals 2 sine 1/2 of x. Then graph the function for 0 to 8 pi. We're going to start by finding our amplitude, which is 2, and our period, which is 4 pi. Remember, here our a value in the equation is 2, and our b value is 1/2. Next, to find the 5 key values, we're going to do our period divided by 4. So we get pi as the value that we're going to be adding on each time to get each consecutive x value. Our starting point is at 0 since we didn't have a phase shift. And we just add pi to get each of these. Now that we have our x values, we can find our y values by plugging each x value into the equation and seeing what we get out. Remember, make sure you pause your video to do this work if the video is going too fast. Next, we're going to plot our 5 key points. Next we're going to label our x and y axis since they weren't labeled. Now we're going to plot our 5 key points. And since the problem wants me to extend from 0 to 8 pi, I'm going to keep my graph going all the way through 8 pi. We can see our amplitude was 2, and the period was from 0 to 4 pi. Next, we're going to look at sine graphs that have a phase shift. So the examples we see are going to have a minus c in the equation, and their starting point is no longer going to be at the origin, where x equals 0, but now it's going to be at x equals c divided by b. Example 3. Determine the amplitude, period, and phase shift of y equals 3 sine of 2x minus pi over 3. Then graph one period of the function. So we're going to first start with finding our amplitude, which is 3. Our period, which is 2 pi divided by b. We get pi. And our phase shift. That's going to be our starting point when we get to our next step. Step 2, we find the 5 key points, starting with period divided by 4. Our starting point is pi over 6. Again, that's because we had a phase shift. And then we're going to take pi over 6 and add on pi over 4. Take 5 pi over 12 and add on pi over 4. Now we need to find the 5 points. So to get the y value, we're plugging in our x values and simplifying. Okay, now we're ready to graph. We're going to start by labeling our x and y axis. And plotting our 5 key points. Since the directions told us to graph one period, we don't need to extend our graph in either direction. Our amplitude we can see is 3, and our period is from pi over 6 to 7 pi over 6, which is, in the end, a length of pi.